Hello, in this video we're going to be talking about operations with functions. The mathematics in this video aren't very complicated. Most of this video is just about the notation required for these operations. Here is what I'm talking about with that notation. If we see this f plus g of x is really asking us to take whatever f of x is and add it to whatever g of x is. Same thing if it's a minus with the multiplication, it'll be that little dot multiplication. Oop, It'll just be that little dot multiplication. This means f times g of x, and then this division. Now, something to note when we look at the domain of these functions, it is the intersection of the things. We want to make sure that both of those functions are happy. So if there's something that's excluded from g, then in this addition or subtraction, that operation with that function also needs to have that same restriction that g had, or same is true for f. So here we're trying to find that sum difference quotient. I've got x square root of x plus 3 and a square root of 4 minus x. So if we look for the sum of f plus g of x, that is going to be f of x plus g of x is what this operation means. So we just add those two functions together, and that's about it. That's all we can really do with it. It's just the square root of x plus 3 plus the square root of 4 minus x. We can't put those two things together. The same thing happens with that subtraction. We can't put those two square roots together, so it just kind of sits as that f of x minus g of x, and then we just subtract those two functions, but that's about all we can do in terms of like writing out that subtraction. When we do this product, we actually can do a little bit. We're multiplying f of x times g of x. And if we've got two square roots, we can multiply those insides together in order to kind of combine them into a single square root. And when we FOIL the two bits of the inside together, we get the negative square root of x plus x plus 12. I think I said that wrong. Square root of negative x, blah, blah, blah. For quotient, it is just f of x divided by g of x. We want to break that up into two separate things. And so with that, those two parts, we want to put the square root on top, square root on the bottom. And then about all we can do to try to simplify this a little bit is we can put it, since there's square roots on the top and the bottom, we can just do a single square root of x plus 3 over 4 minus x. And that's it in terms of like the operations that we can do with that function. In this example, there's even less to be done. So we do f of x plus g of x, f of x plus g of x with that ln of x and the x minus 3. We want to separately add those two together, ln of x plus the absolute value. Those two operations can't go together, so they're just going to stay separate. The same thing's going to happen when we subtract the two. F of x minus g of x, that's what this operation means. Take whatever f of x is and subtract it from g of x. And we get that same ln of x minus the absolute value. This next one, when we're multiplying, last time when we were multiplying and it was the same operation, we were able to put particular things together. It was what we can do with square roots. But in terms of natural log and absolute value, that just doesn't work. So we have just the ln of x times the absolute value of x minus 3. Our quotient problem is just going to be the same thing of just setting those two on top of each other. And then that's it. We're finished. Again, nothing too major in this video. Mostly we're just talking about what this notation means, because this notation can be tricky to look at. So if we see this f plus g of x, that's just taking f of x plus g of x, adding those two things together. And then we're done. That's about all it is. You can tell it's an Aspen. You can tell it's addition and subtraction because of the way it is. Be careful with this one. We're going to be also learning about compositions of functions. This multiplication, that solid dot, means to multiply the two things together. If you see a circle in between those two, it means a composition, which is a different operation that we'll be talking about in another video. But for now, that's it. Thanks. Bye-bye.